Good morning. Hey, Joey, glad to see you with us. Gonna wait a minute, see who we can get to join us. Don't forget to be going to your Google Classroom. This is my daughter playing the piano, by the way. Yep, Google Classroom. When we get done with this, you've got assignments waiting there for you. You can go into our archived videos that I've posted that'll explain what you're doing in them. If you have any questions, you can email me. You can send me a message. I monitor my messages from 8 in the morning till probably 10 at night. Matter of fact, last night I was answering some at 11. So don't be afraid to ask me questions if you don't understand. Usually what you have is you have an assignment, like a PDF, and then you have a blank Google Doc that you can type on to type your answers. Make sure you are telling any of your classmates that you communicate with to get on these broadcasts. Excuse me. I'm doing live broadcasts Tuesdays and Thursdays. Other teachers are doing them at different times. There won't be anything next week. Next week is officially our spring break. However, you should have been on last week. We've been doing them for a couple of weeks now. So if you've been sitting at home playing video games, you've missed out on a lot. So we need to be on top of this. So we've been talking a lot, and since you're the one here right now, Joey, I'm going to talk a little bit about some of the stuff we've been talking about. And there's an assignment in there about forces in motion, about balance and unbalanced forces. I'm going to show you an instrument. This is spring-loaded. Okay, and it has a little hook. By the way, say hi to Harold. Hi, Harold. Mr. Fosnight, if you can explain to him that he's already actually in the class. He just needs to go to it. This is basically a Newton scale. And you probably can't really see, maybe you can. Up there is an N. And so each time that I put force on it, that is 1 Newton of force. That is 2 Newtons of force, 3 Newtons of force, and 4 Newtons of force, and 5 Newtons of force. What that is actually a spring in there, okay? And so we can actually measure a force and determine how many newtons it would actually take to move something. I was lucky enough to get into the school and get a couple of these yesterday. Now this one measures up to 5 newtons. There are other ones. I have 2 different ones here. This is a little bit more precise. This only measures, you can see the N up there for Newton. This only measures up to 2.5 newtons. So you can imagine, you can probably see that spring, it's a lot easier to pull than the spring in this one. It's more of a rigid spring. And then I have this one. If you can see, might be difficult to see. There's our Newton, and this one actually goes up to 20 newtons. And one of the things we do when we're in school is we measure, we do a lab where we measure how many newtons it takes to move different objects. Here's the thing about this. We think of force a lot in terms of gravity, and gravity does play a role in it, but a Newton can be measured this way, this way, this way, and this way. It doesn't matter. I'm going to go back to this one. And so one of the things I have is I just brought something that we probably all have lying around the house somewhere, would be a wrench of some sort. Okay, so if I look at this, and you probably can't see it, maybe we can't. So that is right there. Okay, and so I'm going to take that off, and if we look at where that mark is, let's see if you can see that. Can't really see it. There's actually a 1.0 there. So this 14 millimeter wrench that I had, it took about 1 Newton of force to lift it up. A different size object would give us a different result. I've got these two type of wrenches. This might be too heavy for this scale altogether, and it is. You can see it's going all the way to the bottom. And so we're not going to get an accurate reading out of that one. Then we would want to change and actually go up to a different scale. Remember, this one goes up to 2.5 newtons. This one goes up to 5. So let's use this one next. And let's see where this brings us, or do we need to go to the next one? So that's hanging freely. So you have to be a little bit patient. Okay. And I'm going to put my finger where that is, and then I'm going to take this off so I can get this up to the camera. You could actually see that number there is number 3. So whereas this wrench took 1 Newton of force to lift up, this larger wrench actually took slightly over 3 newtons of force to lift up. So we can measure anything with newtons. We can also measure how something slides. And I'm going to attempt to get the camera down here and see if we can get it so you can actually see on a countertop too. I don't know how well that's coming across, but and on this scale, and you can't see it with your camera, but on this scale, that spring stretches out to about 0.5 Newton until it decides to pull that. So I'm going to change the scale and go to the smaller one. And yep, it's actually just slightly under 0.5 Newton. But what about this one, which was even smaller? Okay, that's about 1/4 of a Newton. So it's not necessarily whether we're lifting things up in the air. A Newton can be measured as a pulling or even a pushing force. It's a lot easier to measure as a pulling force with this type of equipment. You would have to have a compression spring. That's a spring that, this type of spring is at rest when it's together. And you pull it apart and it increases the tension, it's at rest. There are other springs, kind of like the springs on your car, which are at rest when they're expanded, and when they're compressed under pressure, then that builds up the pressure. Yeah, and you can see in here, there's actually this little plunger, and just like reading numbers on a ruler, we measure numbers on a ruler, we can measure numbers on this scale by where that top of that plunger is. You can see where there's kind of a line going around there, and wherever that line goes to, like that's at 3, that's at 4, and I don't know how clearly you can see that. Maybe that's a little bit better. So right there would be 3 newtons, that would be 4, and that would be 5. Now I'm pulling on that. I would definitely get tired if I did this for more than a few minutes. That spring has some tension. This spring has a lot less. So it is just like measurements on a ruler when we measure these newtons. Okay. And then we can use that to measure just about anything. I'm not going to do anything crazy because you know what'll happen? I'll drop it on my toe. That's one thing about working from home like we're doing is I don't have to wear shoes, do I? So I presently don't have any shoes on. I know as soon as I try to lift something really heavy, I have a whole bunch of stuff to look at here. This is interesting. This is actually a little piston out of a motor. Let's try this. My guess is it's not very heavy. And let's see if you can read that, where that plunger is. Can anybody read that and want to tell me what that actually reads, right where that line is? And you don't have to be exact. That's right, Joey. It's the 0.05. It's a half a Newton. That's actually a half a Newton, the amount of force that it takes to lift this. So there is a formula. Something that weighs approximately a pound would take 4.45 newtons on Earth. Why is that important? Well, gravity can affect the way things slide, right? If we are in a place with less gravity, we could pull something along a table a lot easier if there wasn't also gravity pushing down on it. So a lot depends on what you're trying to do. Are you pulling up? Are you pulling down? Are you pulling sideways? Okay. So let's talk about the assignment that was given last week. And I'm going to use this tissue box as our example. Now, first of all, right now, if I let go of this, what's going to happen to it? I think you guys know the answer. If I let go of it, it's going to fall, right? What is acting on it that is causing it to fall to the ground? And I'm going to take a sip of my orange juice. So gravity's acting upon it, right? And so gravity is actually a force that's pushing down. Really, we can measure it in newtons. The ground itself is pushing up against it, and we can measure that. But I also can do this, right? I can push it this way. I can push it that way. So at any one time, I could have multiple things pushing on this box, multiple vectors pushing on this box, causing it to go in any direction. And so I have, you can see I've drawn arrows on the box. And so I could put any amount of numbers on this. I'm going to do it in, maybe I'll do it in pen. So this basically has to do with simple math. So if you see this, I have 7 newtons on this side and 5 newtons on this side, which means if I was pushing it, this is 8th grade. See you at 11. If this is, if I have 7th on one side and 5 on the other, what direction is this going to go? It's going to go in that direction. So one of the things we have to do on the worksheet, Joey, is look at all the arrows, okay, and say, okay, so I have 7 and I have 5. You take whatever the larger number is, which is 7, and you subtract the 5. So 7 minus 5. What would that would be called the net force. When you're subtracting, what you end up with is the net result. 10 minus 5 would be 5. So Joey, what's 7 minus 5? And we're going to assume that what's coming from here is even with what's coming from here. Yeah, so there would be a net force of 2 newtons. That's correct. So that means that since this side is greater than this, you'd end up with 2 newtons that are pushing it this direction. Now, what if this was 70 and 50? It would be 20 newtons. This would probably be going a lot faster. What was that just went by? It's box tissues. So the amount of newtons pushing or pulling, remember, it can be a pull too. It could be, this could be pushing in that direction and that can be pulling in that direction. And that, in that case, we would add them together. So whatever direction the arrows are going is, if we have 2 arrows that are facing each other, you take the larger number, subtract the smaller number. If both arrows are going in the same direction, you need to add those together. Just think you're basically doing addition or subtraction with this. And so you have a worksheet that has boxes and it's just saying, okay, what direction is something moving based on adding the numbers or subtracting the numbers. 7 minus 5 is 2. It's going this direction 2. If this was 5 and that was 5, it would be 0. That means it's not moving in this direction or this direction. It's staying still. We talked about friction quite a bit, and I'm not going to review that right now because we're trying to keep these short, and I think Miss Miller, I believe, is going on at 10:30, so we got to get off of here. If you guys have any questions, please let me know. I'm going to make sure you have my email. And you can also, through Google Classroom, all your teachers, guys, the governor said yesterday that we're going to be out till May 1st. That doesn't mean this is a vacation. We're doing schoolwork. Districts all over the state and really all over the country are getting set up to do what we're doing here, what we've started doing already. is these live streams. And so this is what your schoolwork is. This is what your grade is going to be based on, and what's in Google Classroom. So you are expected, Joey, thank you for showing up, and Cadence. By the way, I saw your message this morning, and you're expected to do this. And the beauty of it is it's not even every day. And so make sure you are communicating with any of your classmates about when the broadcasts are, and about getting the assignments done. It's pretty important that you do it. So, Joey, I know you're friends. There's the class code. Mr. Fosnight put it on there. Write that down. Text it to yourself. Text it to somebody. Get into our Google Classroom. Get signed on. Get the work done. Understand every teacher at this point has stuff loaded in Google Classroom. So if you haven't done anything for a couple of weeks, you're probably quite behind. Don't worry about due dates. If it's late, don't worry about it. Just get it done. And please, please, please ask questions. And if you don't have any questions at this point, I'm going to play some bumper music and get out of here so that Miss Miller can get her broadcast done. And by the way, I don't know what grade she's doing when, but you probably should log on to that. Cadence, if you're still with us, make sure you're telling your classmates. There's a lot of people I haven't seen. Hope you guys have a good day. I really do miss you guys. I even missed Mr. Fosnight. Take care.